So welcome one and all. So in today's lecture we will discuss about Bernoulli's differential equation. So what is a Bernoulli's differential equation? So in other words we can call it as equations reducible to linear. So the equations which are not completely in linear but possible to convert into linear. So such type of equations comes under this Bernoulli's. So now we will see what is the general form of this Bernoulli's differential equation and how to solve. Okay, so first of all we will see what is the general form. The general form is something like this: dy by dx plus p of x into y is equal to q of x into y power n. So this is the general form. As in linear, in the linear we have two, as differential equation is linear in y and differential equation is linear in x. Similarly here also we have two different formats. One is linear in y and another, Bernoulli's, the general form in Bernoulli's in y and Bernoulli in x. In the sense which are in this format can be converted into linear. Similarly in the form of x also. So in the sense here y is the dependent variable and x is the independent variable. Similarly another format is x is dependent variable and y is independent variable. So now whenever we have an equation something like this, so which is nothing but known as the Bernoulli's equations in the first order. Now how to convert this one into linear? Now we will see that. So to convert this one into linear, so in the linear we know that the standard form is dy by dx plus p of x into y is equal to q of x only. But here we have that y power n as an additional term. So now we will have to remove this term y power n, and then later on we have to convert this one into linear. Okay, and it will be converted. So just to remove that, so just you divide on both sides with the y power n, then we can write it as y power minus n into dy by dx plus p of x into y power 1 minus n is equal to q of x. So just by dividing it on both sides with y power n we can write it. Now still this is not converted into the linear format. So for that now we will eliminate this term y power 1 minus n. So just you eliminate that y power 1 minus n with the help of some variable t. Now we introduce some new variable t. Okay, now we will differentiate it on both sides. Then we will see 1 minus n into y power. So 1 minus n minus 1 we will get. So minus 1 and plus 1 will cancel out and we will get only y power minus n into dy by dx is equal to dt by dx we get. Okay, now here the term here we have is y power minus n into dy by dx. Okay, so to get it we can write it as y power minus n into dy by dx is equal to 1 by 1 minus n into dt by dx. Now we have to replace all these things in equation. So suppose this is the equation 1, the given one. So this is the converted one, equation 2. Now in this equation 2, now you replace y power 1 minus n with t and y power minus n into dy by dx with something 1 by 1 minus n into dt by dx. Now we will replace these two here. Okay, and let us see what are the changes we will identify here. If we substitute all these things in equation 2, therefore equation 2 transforms to or changes to whatever it may be. Okay, so this y power minus n into dy by dx can be written as 1 by 1 minus n into dt by dx, okay, plus what next we have p of x. P of x we can write into, we have y power 1 minus n, that y power 1 minus n can be written as t, so which is equal to q of x we have. Now still it is not in linear. Okay, so for that now you multiply with the 1 minus n on both sides. then we have, or we will get dt by dx plus 1 minus n into p of x into t is equal to, right side also will get 1 minus n into q of x. So now better what we will do is that 1 minus n into p of x and 1 minus n into q of x we will replace with some new functions, so that now this equation now seems to be in a certain standard format. So dt by dx into some p1 of x we can write p1 of x into t is equal to q1 of x, some q1 of x we can write it. So where p1 is equal to, so it is very easy to observe this, p1 is 1 minus n into p of x. Similarly q1 of x is also same as 1 minus n into q of x. Now if we observe this dt by dx, this equation dt by dx plus p1 of x into t is equal to q1 of x is nothing but a linear differential equation, first order linear differential equation in t, not in y. So therefore later on it can be easily solved. Okay, so for this type of equations already we have discussed that the integrating factor is nothing but given as e power of integral p1 x dx. So here instead of p, here we have p1, therefore integrating factor is e power integral p1 of x dx, and the general solution is given as, so here instead of y, here the dependent variable is t, so therefore instead of y here we will get, so the general solution as t into, okay, integrating factor is equal to integral of, instead of q here we have q1 of x, q1 of x into integrating factor, okay, dx plus c, where c is an arbitrary constant. So now later on we have to substitute what is this t. T is already here, we know that y power 1 minus n, and we substitute the integrating factor and all, and finally by solving this integral on RHS side we will get the solution for the Bernoulli's differential equation. So let me once again conclude. So Bernoulli differential equations are also in the two forms. One, when the y is the dependent variable, x is independent, that is the first form. Another form is x is dependent and y is independent, that is the another form. So the Bernoulli's differential equations are also nothing but, or can be treated as the equations reducible to linear. So whenever we have this type of form, means where y is dependent and x is independent, and it is in this form dy by dx plus p of x into y is equal to q of x into y power n, just by dividing it on both sides with y power n and taking that y power 1 minus n as t. So totally this differential equation that transforms to a linear differential equation in t, and later on it can be easily solved by using the procedure that what we have adapted to solve a linear differential equation. So this is the procedure and all. So in the next video, so we will see how to solve the Bernoulli's differential equations and all. Thank you and all.